Hi students, welcome to this session. Our lesson is refraction of light. We studied refraction of light at plane surfaces in our 9th class. At plane surfaces. Just to recall some main points. What is refraction? Refraction is bending of light. Bending of light. When does the light bend? When light ray enters from one medium to another medium. One medium to another medium. Medium 1, medium 2. When light ray enters from one medium to another medium, then at the interface means the surface which separates two mediums. Suppose here air medium is there, here water is there. So two mediums are there, air and water. This is the separating surface of two mediums, that is called interface. When light propagates from one medium to another medium, this is the light ray. At the point of incidence we draw normal. This is the normal. At the point of incidence it bends. It bends. This is the refracted ray, this is the incident ray. Incident ray, after refraction, this is the refracted ray. And one another point, why does the light bend? Because due to the changes in the different speeds in different mediums of light. We know very well in vacuum medium, the speed of light is 3 into 10 to the power of 8 meters per second. Liquids approximately 2.25 into 10 to the power of 8 meters per second. In solids 2 into 10 to the power of 8 meters per second. In air and vacuum approximately same, 3 into 10 to the power of 8 meters per second. That is the speed of light. When light travels from one medium to another medium, the speed is changing. Due to the change in the speed, the light will bend. So this is the phenomena of refraction. Next, another point. When the light travels from rarer medium to denser medium. What is rarer medium? The medium in which the speed of light is more is called rarer medium, and the speed of light is less medium is called denser medium. Here water is denser medium, air is rarer medium. When light ray travels from rarer medium to denser medium, it's bend towards the normal, and when a light ray travels from denser medium to rarer medium. This is the denser medium now. This is the rarer medium. This water here. Here it is air. At the point of incidence, we took normal here. This is the normal. At the point of incidence, the refracted ray after refraction, it moves away from the normal. This is refracted ray, this is incident ray. When a light ray propagates from denser medium to rarer medium, it moves away from the normal, the refracted ray. When it is propagates from rarer to denser, it just moves towards the normal. About these topics and Snell's law. sin I by sin R is equal to N2 by N1. These are the N1 into what are the N1 into? These are the refractive indices of these mediums, different mediums. Refractive indices. These are the some topics what we have learned in 9th class. From that we recalled 2-3 points which is helping in our lesson. Now refraction of light. 8. Curved surfaces. Curved surfaces. How the refraction will occur at curved surfaces. We will understand this by a small an activity. Dear student, observe this arrow. Now we observe this arrow through a empty glass. This glass is filled with air. Empty glass. Empty glass consists air. Now observe how this arrow appearing. How could you see it? So it is appearing big or small? Yes, it is appearing small in size than its actual size, and it is upright as it is. Okay, this is appearing as small. When we take water in a beaker, what happens? We observe. I took water. Dear students, now observe the arrow. It is reversed in direction and it is enlarged, big in size. It is enlarged. Now observe through the air. Through the air, it is small, diminished. And when we see through the water, it is enlarged in size and reversed. I kept the lemon in a glass. How this lemon size is? Its actual size. When I poured water in the beaker, now observe the size of the lemon. How the lemon is appearing? It is very big than its actual size. Why is this happen? Why the lemon is appearing big than its actual size? Let us observe. The arrow. Dear students, from this activity, why the lemon kept in water appeared big in size than its actual size, and the arrow mark reversed and enlarged when we observe through the water, glass of water. Let us understand by the phenomena of refraction through curved surfaces. Okay, when we observed through the empty glass, what happened? First, if it is arrow, the light ray from an arrow propagates in air. This is the air and strikes at glass surface. This glass surface, as observe here, it is convex surface. We know that it is bulged here, bulged outside. So this bulged outside is convex surface and strikes convex surface, enter into the glass air. So again it travels in the air and strikes inner surface here, inner surface. This is curved inverse. This is concave surface and it exits from the outer side. This convex surface. Again it should enter into the air. The refraction takes place at 2 times here. At convex surface, at concave surface. And when it is filled with water, it is no air in the position. When it is filled with air, that is acts as denser medium. We assume that the glass and water are same medium. The refractive indices are same. Actually they are not same, but we assume that the both are same. taking one medium, we assume that the glass and the water refractive indices are same. So here two mediums, air and water. What happens the light ray? Let us observe this phenomena by ray diagrams at convex concave surfaces, rarer medium, denser medium, denser medium, rarer medium. This is the glass surface from the top position. This is the center of the sphere, spherical shape na. The center of the sphere. This center of sphere is center of curvature for this curve. Center of curvature. We know very well. We learned in mirrors also reflection of light. The midpoint is called pole for this curve. This is the convex curve. It is concave curve. So this is the center of curvature for this curve, and the midpoint is called pole for this curve. So we know how the normal will take. From this position, it is the tangential line. From this is taken as normal. From the surface of the curve to the center of the curvature, the distance is normal. Here these are the normals from any point. Okay. From this we understand the phenomena of refraction of light rays through convex and concave surfaces, from air to water, water to air, rarer medium to denser medium to rarer medium. First, refraction at convex surface from rarer medium to denser medium. Rarer medium to denser medium. This is center of curvature, this is pole. The line which passes through the center of curvature and the pole is called principal axis for this curve. Now a light ray, a parallel light ray from the object, this is a parallel light ray, strikes at convex surfaces. So it is rarer to denser. Here assume that this is water. This is water, so it is denser medium, it is rarer medium. Light ray propagates from rarer to denser. What happens then? We studied at plane surfaces. Now this is normal at the point 2. This is normal. So when light ray passes through rarer to denser, it bends towards the normal. Refracted ray after reflection, reflected ray bends towards the normal like this. So then the refracted ray converges on principal axis. Next, second case, a convex surface. Now denser medium to rarer medium. Now denser medium to rarer medium. This is center of curvature, pole. Now here it is water. Here it is water, means it is denser medium, it is rarer medium. When a light ray propagates from denser medium to rarer medium, what happens? It strikes on concave surface. Next, what we have to draw? We have to draw a normal to this position. This is the normal. These are normals. So when light propagates from denser medium to rarer medium, what happens? it moves away from the normal. It moves away from, this is the normal, it moves away from the normal like this. The refracted ray moves away from the normal. So it is appearing as diverging. It is converging, it is diverging. Next case, concave surface. Let us take concave surface from rarer to denser medium. It is center of curvature. This is the concave surface rarer to denser. It is denser medium now, it is rarer medium. When a light ray traveling from rarer medium to denser medium strikes at concave surface. Concave surface. What happens then? Here it is the normal. It is the tangential line. Here it is the normal. So when it moves from rarer to denser, what happens? It bends towards the normal. Where is the normal? This is the normal. So it moves towards the normal like this. It moves towards the normal. This is the normal. So it is diverging. Here it is diverging. It moves towards close to normal. And next case, concave surface. Now denser to rarer. This pole of the curve. Now it is denser medium now. It is denser medium, it is rarer medium. Now a light ray traveling parallel to the principal axis. These all rays we are taking that parallel to the principal axis, light rays. And at the point, this is the normal here. Here it is the normal. Okay, now what happens when light ray passes from denser to rarer? It moves away from the normal. Here normal it is there. It moves away from the normal like this. It moves away from the normal. This is the normal. It moves away very distance. So in this case, the refracted ray converges on principal axis. If you observe, in these two cases, it is convex surface. When light ray enters from rarer to denser, it is concave surface. Sorry, it is convex surface striking at convex surface rarer to denser, striking at concave surface from denser to rarer. In both cases, the light ray converged, means moves away from the normal. Here away from the normal, here towards the normal, but converging at the principal axis. In these two cases, here concave surfaces strikes rarer to denser, here convex surface denser to rarer. It is diverging ray. So if you understand this simple logic, when light ray moves from rarer to denser, it moves towards the normal, and when light ray moves denser to rarer, it moves away from the normal. This is the main point. And second main point is draw the normal. Draw the normals at the curved surfaces. After that, towards the normal, away from the normal, towards the normal, away from the normal. And then third point is converging, diverging, diverging, converging. This should be identified. These help us to draw ray diagram in our previous activity. Okay, let us draw. We observe now what we have observed, the refraction of light. How does the light refract at concave, convex surfaces in different mediums? Now this will help us to draw ray diagrams what we observed in our recently activity. Here it is blackboard or paper. Here it is an arrow mark, drawn an arrow mark in our activity. We observed through a glass. Okay, now the glass is spherical in shape, so the upper part of the glass. The upper part of the glass observed from the top of the glass. So this is the center of the sphere. It is spherical in shape, center of the sphere. This is the center of curvature for this curve, this convex curve and this concave curve. Okay, this is the arrow mark which we draw on board. Now let us assume a ray that a ray from the top of the arrow, coming and strikes on which surface? Convex surface. Just we have observed here, it is air, it is glass. So glass is denser medium. When it enters in glass, here little bit bending towards the normal. This is the normal here. This is the normal here. So it bends here little bit towards the normal. And this denser to rarer. What is denser here? This is the glass. Denser to rarer. So when light ray moves denser to rarer, it moves away from the normal. So this moves away from the normal like this. Again it is glass, denser medium. Here little bit bending this happens towards the normal. This is normal here. Little bit bending here, and from denser to rarer, again away from the normal. Again away from the normal. This is the top ray, top of the arrow. Next, second ray, which is from the bottom of the ray, bottom of the arrow mark. The ray coming from bottom of the arrow mark and strikes at convex surface. Here also little bit bending here. This is the normal here, towards the normal. And denser to rarer, it moves away from the normal. Away from the normal. And here little bit bending towards the normal here. And it moves denser to rarer away from the normal like this. This is the refracted rays. So the light ray appears, or the arrow appears here like this. It is the light ray, incident ray from the top of the arrow and meets here. It is the light ray from the bottom of an arrow. It refracts here and here. Refraction occurs 2 times here. Here glass is very thin, negligible it. So it is how it is the smile. It is object, it is image. So in this case we observe very diminished upright image. And when it is poured with water, what? This is an arrow. Now it is filled with water here. We assume that this glass and water are the same, has the same refractive indices. So it is treated as only one medium, glass and water, for our convenience. It is hair here, so it is rarer medium. It is again denser medium. It is again rarer medium. Okay. From the top of the arrow, a incident ray coming and strikes at convex surface. From rarer to denser, it is the center of curvature here. From rarer to denser, it is normal. From rarer to denser, what happens? The refracted ray bends towards the normal. Very good. Bends towards the normal here. This is the normal, bends towards the normal like this. So this ray strikes here at concave surface. Now this is denser medium. The light ray moving from denser to again rarer. What happens here? This is the normals here. It moves away from the normal. It moves away from the normal like this. This is the normal. It moves away from the normal. So it is the refractive ray 1. It is incident ray 1. So this is the refracted ray of this incident ray. It coming downside. Next again the second incident ray I2 is striking at convex surface here. What happens? It is rarer from denser. It is propagating from rarer to denser. Then this is the normal. It moves away from the normal here. Moves away from the normal here. Like this. So this is now denser medium. It is propagating from denser to again rarer. So here this is normal. It moves denser to rarer and it away from the normal like this. So this is the R2. It is diverging. So then this ray, this is the top of the arrow, means here it is. This is the bottom of the arrow. Like this. So it is inverted and enlarged. The refraction occurs at 2 times. That's why in an empty glass the arrow observed diminished and upright virtual image with filled with water. When filled with water, the arrow mark appeared as enlarged and inverted image. This is the way the light refracts at 2 times. Are you able to understand, students? Now observe the lemon also. When the lemon in the glass is appeared big, when it is poured with water. Why it is appeared? Let us see. If you observe, this is the center of the sphere. Now observe this. This is lemon, actual lemon. When it is filled with water, what happens? It is denser medium now. The glass filled with water. Assume that the rays are here traveling like this. Two rays. Denser medium to rarer medium. Outside of the glass it is rarer medium. Now it is denser medium. From rarer medium to denser medium, it moves away from the normals. It is the center now. Again, it is away from the normal. When we diverge it, when we extend it back, the refracted rays, they meet at some point. Now we take another two rays which goes like this. The incident rays from lemon. Again they refracts like this, diverge. These are the refracted rays. When we extend it back, they meet at some point. These are the images of the lemon. Like that, in all direction, the lemon is spherical in shape. So in all direction of light rays, they will be diverged like this. If extended them, they will meet at some point. Like this. When we extended them, they meet at some point. Like that, these points are making spherical shape again. Are you able to understand? So this is the appearing lemon. This is actual size of lemon. This is apparent size of lemon. Apparent size means what we visible. The visible size of lemon, what we have observed outside. So the lemon is appearing as enlarged when it is filled with water. Okay. This is the refraction phenomena from rarer to denser, denser to rarer.